All right, guys, this is the second of our two little lessons this week, talking about the structure of the atom. So just to review the last lesson, there's protons, neutrons, and electrons, protons and neutrons in the nucleus, electrons in the outer shell. The electrons are negatively charged, negatively charged, negatively charged, and then the protons are positively charged, and the neutrons have no charge whatsoever. That gives the nucleus an overall positive charge, and then the outside of the atom an overall negative charge. Believe it or not, most of how chemicals react with each other and react to their environment has to do not with the protons and the neutrons in the nucleus, but by the arrangement of the electrons around the nucleus. This particular diagram here doesn't really do the atom justice. There's a very particular way that these electrons arrange themselves around the nucleus. So we use a Bohr-Rutherford diagram named after Niels Bohr and Ernest Rutherford to represent where these electrons are around the nucleus. So in a Bohr-Rutherford diagram, a circle is drawn to represent the nucleus of the atom. You write the number of protons and the neutrons in that circle. That's a skill that you gained from the last lesson. So if this is element number 3, I suppose that would be lithium. Anyways, it doesn't matter what it is, but you write the protons and neutrons in there. The electrons are shown in the circular orbits around the nucleus, but you'll notice there's 2 in the first orbit, the orbit closest to the nucleus, and then 1 in the next orbit. Of course, if there's 3 protons, then that means there's 1, 2, 3 electrons, right? That's a skill you were supposed to have gained last time. You should draw your electrons as far apart as possible since they're negatively charged and do repel each other. Now, I'm going to show you a little bit different way of doing it than that. It's true in the first orbit, they should be apart, but they tend to pair up in other ones. Each orbit has a maximum number of electrons it can hold, and I just memorized 28818 because you're never going to need to use more than 4 orbits, not in grade 9, 10, 11 chemistry. Electrons will always occupy the orbit closest to the nucleus, so you fill them first. So let's take neon as an example. All I need to know about neon is the atomic number and the mass number. I know somewhere in this PowerPoint I have a periodic table. So neon is element number 10, and its mass number is 20. You just round that off. So 10 and 20. Let's go back. So I'm going to change my color here. What's going to show up nicely for me in there? Let's say green. Let's see how that looks. Yeah, that looks okay. So protons, 10. Neutrons, 10. How do we know it's 10? Because the mass number was 20. So that means 10 protons, 10 neutrons. And then I just have to put the electrons around. How many electrons should it have? It should have 10 electrons. So that means, following this rule, occupy the closest orbit first. So there's 1 electron. They're going to look a little ugly here. There's 2 electrons, 8 more to place. 3, 4, 5, 6. Now here's where I'm going to break this rule of spreading them out as far as possible. They do tend to pair up. Especially in the second and third and fourth orbit. So I went 1, 2 in the first orbit and I made them apart. And then I went 1, 2, 3, 4. After 4, they will tend to pair up, and it actually makes it easy to arrange them. And now I've got my total of 10 electrons, 2, 4, 6, 8, and then 10 in that one. We're not going to write this down right now, but I want you to pause this first of all and walk yourself through filling in the orbit here around this neon atom. I want us to mentally note that the orbit, the last orbit we filled, which is orbit number 2, it can hold 8 electrons. And how many electrons did we end up putting in it? 8, right? So we would say that orbit, its outer orbit, is full. Now, how about for magnesium? I believe magnesium is number 20 But let's take a look. Haha, I was way off. Magnesium is number 12, and one of its family member, calcium, is number 20. So magnesium is number 12, so that means there's going to be 12 protons. How many neutrons? Well, let's take a look. Where's that periodic table? It's got a mass number of 24, so that means I'm going to have 12 neutrons as well. Again, if this was a test question, that's a small part of the question. The main part of drawing Bohr-Rutherford diagrams is arranging the electrons correctly. So magnesium is going to have 12 electrons. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many more? 2 more. 11, 12. All right. So I really want you almost to ignore that rule. I know somewhere on this PowerPoint it says that electrons will space each other out as much as they can. You know, doing it like this is a nice organized way. What really matters is how many electrons are in their outer orbit. For magnesium, it doesn't even matter that there's 2 in the first orbit and 8 in the second. What matters is there's 2 outer electrons. So its outer orbit, the outer orbit of magnesium, is not full, whereas the outer orbit for neon was full. Now, down at the bottom here, it says draw Bohr diagrams for the first 20 elements. Well, I'm not going to do that for you because that's essentially what your assignment is today. But I will take a couple just for fun and make them. Why don't we do carbon? Carbon's got an atomic number of 6, an atomic mass of 12. I've got a blank one here. So carbon has 6 protons, 6 neutrons, and it's going to have 6 electrons. So usually I draw these as dotted lines, but I'm just doing the best I can here. So I'm going to have 1, 2 electrons, and I need 4 more. So I'm going to have 1, 2, 3, 4. There's a Bohr-Rutherford diagram about as good as I can do for carbon. All right, let's do maybe 2 more together. Let's do a Bohr-Rutherford diagram for let's do one for hydrogen, the easiest one. Now, hydrogen, just going to double check, has an atomic number 1 and a mass number 1. So it has 1 proton, but if its mass number is 1, that means it has 0 neutrons. It only has 1 electron, so 1 electron in the first orbit. That's it. Let's do 1 more together. So let's look at, now you'll notice we're not, if you do the first 20 elements, you're not going at all into the transition metals at all. Like there's nothing that we're going to deal with in here, and we're not going to deal with them. If you only go to element 20, which is all we have to do, then there's no need to go into the transition elements. So you're only dealing with group 1, 2, 13, 14, 15, 16, 17, and 18. Let's do, I don't know, a big one. Let's do chlorine. So 17 and 35. It's going to be bigger. So 17 protons for chlorine. And if it's 35, then it's going to be 18 neutrons. That's one of the examples I think that we used in the last lesson. I don't know, I just remember those numbers. So there's my nucleus. First orbit's going to, of course, have 2. I've got to get to 17 electrons here. So I know this one's going to be full. I'm just going to fill it up right now. I'm even going to change. I'm going to change colors here just to make it look a little nicer. So we're going to use red. So my electrons are all going to be in red. Oh, that doesn't look that good. And I'm going to count up what I have so far. 2 in the first orbit, 8 in the second, so that's 10. So I need 7 more. So I need another orbit. I'm going to go back to green. There we go. And now I'm going to go back to red. And so what do I need 7 more. So 1, 2, 3, 4, 5, 6, 7. And in this one, I would say that the outer orbit is almost full. It needs 1 more to be full. Now, I keep mentioning this, how many more do they need to be full? Some of them are full, some of them aren't, because On your assignment today, you're going to be drawing Bohr-Rutherford diagrams for the first 20 elements. And actually, I can back out of this right now and and show you what that assignment is going to look like. So it is right here, Bohr diagrams. It's a PDF. So you can fill this out if you have the ability with something with a touch screen to actually write right onto the PDF and fill this out. All right, you'd have to zoom into it and fill it out with the protons and neutrons and then arrange the electrons around it correctly. It gets a little dicey when you get to element number 20 and you got to place 20 electrons around calcium. So, keep your diagrams pretty small, pretty tight. If you can't write on this document, then the next best way to do it would be to print it and do it in pencil so you can erase mistakes and submit a picture of it. And then finally, if you can't do either of those, well, you're going to have to make your own table. Just the best you can. Get out a straight edge and make period 1, 2, 3, 4. Make these boxes and fill it in. The questions, now again, you remember me talking about why it's important to remember how many electrons are in their outer orbit. It says, what do you notice about the number of energy levels within the same period? Energy levels means the number of orbits. What happens to the number of energy levels as you go down a group? Groups are the columns, remember. The periods are the rows and the groups are the columns. What does the period number represent? And what do you notice about the number of electrons in the outermost orbit for elements in the same group? So those are going to be, you won't be able to answer those questions until you fill in this table. Once you fill that in, you should see a pattern as to how many electrons are in the outer orbit for elements in the same group. I think that's all I have to say about that, and I can give you more detail and more instruction on how to do that upon your request. If you get stuck at any point, don't hesitate to leave a question in the comments, and I'll answer it as quickly as I can. All right, guys, I think that's it, and that's going to be it for this week. Submit this along with the assignment with atomic structure, and that's all you guys have to do. And just stay tuned. After that, you can just enjoy your weekend. All right, guys, that's all for now. Good luck.